Aloha, everyone. I'm Jarek Larson,
And I'm Jordan Peterson.
and this is our MD2 High Yield Osteology Review. This block, we spent time in the osteology lab and we picked up some really interesting tidbits of information that we thought would be useful to pass on to you, as well as just go over some of the most high yield relevant osteology for the MD2 anatomy exam.
To get started, this is a brief snippet of the fair games list that we were given on the share drive. Not everything on the list is present here, but this is all the stuff that we'll be covering in this presentation. The first topic is specific landmarks on the thoracic vertebra. This is a list of the ones we will cover on the next few slides. The body is likely the most obvious feature and is highlighted here in light red. We will discuss it a bit more later on, but suffice it to say that the body size is one of the easier ways to differentiate between thoracic and lumbar vertebrae. Next up is the pedicle, highlighted here in a light blue color. The pedicle is essentially the thin part of the walls of the vertebral foramen, but only on the superior side or when looking from the top down. This will make sense later when we discuss the vertebral notch and the intervertebral foramen, but for now just remember that the pedicle is what connects the body to the lamina. Speaking of which, the next landmark is the lamina. The lamina, highlighted here in green, makes up for the posterior wall of the vertebral foramen, which is shown here highlighted in purple. The vertebral foramen is specifically just the hollow portion of the vertebral column that houses the spinal cord. The spinous process is likely also obvious to you, but for the sake of clarity, it is highlighted here in yellow. There are two transverse processes, and both of them are highlighted here in dark red. If you can identify the transverse processes, you should have no trouble identifying the transverse costal facet, which is highlighted here in bright pink. In anatomical terms, a facet is defined as a smooth articular surface. Therefore, it should make intuitive sense that the smooth surface on the transverse process is a facet, and it's a costal facet because it's the location where the costal bones or ribs interface with the vertebrae. Now, if we look at the thoracic vertebrae from the side, we can more clearly see some of the other important landmarks. First up is the superior articular process, highlighted in red. The articular surface is specifically on the posterior surface of this landmark, and it interfaces with the inferior articular process, which is shown in green. The inferior articular process's articular surface is on the anterior side, and when combined, they together form a surface that allows smooth articulation between vertebrae. Next up, we have the vertebral notch. This is highlighted in purple, and it is also the thin part of the wall that makes up the vertebral foramen, but only on the inferior surface, or when looking from the bottom up. The pedicle of a superior vertebra, combined with the vertebral notch of an inferior vertebra, together will make up the intervertebral foramen, like two halves of a whole foramen, and once more, this will make more sense in the next slide. Lastly, we have the superior and inferior costal facets, or demifacets as you might know them. They are highlighted here in blue and yellow respectively. These two facets together are also two halves of a whole costal facet. By this, I mean that the two demifacets come together between two vertebrae to make up one whole facet joint for a rib. This, combined with the transverse costal facet, make up the 3 points of contact for the ribs. Just as a quick reminder, it's important to remember that when thinking about superior versus inferior, always adopt the point of view of the specific bone you're speaking about. This might be obvious, but it can be confusing if you ever think it. For instance, the superior surface of a rib would interface with the inferior costal facet of a superior vertebra. If that's confusing, just remember what I said before. Name the bone landmark from the point of view of the bone itself, not any bone that it articulates with. On this slide, you can see what I said before about the intervertebral foramen, which is the hole that is created between two adjacent vertebrae. Its superior side is composed of the vertebral notch of the superior vertebra, and its inferior side is composed of the pedicle of the inferior vertebra. Now for contrasting the different types of vertebrae, there are a few different details that we've teased out that should make things simple. For starters, the cervical vertebrae are the only vertebrae that have these holes on the side, called the transverse foramen. These holes are what house the vertebral artery. If you see these holes on the side of a vertebra, it's 100% cervical. Some finer details you might be able to appreciate are the bifurcations on the spinous processes. These are not present on every cervical vertebra, but they are definitely a helpful visual cue. Lastly, the body of these vertebrae is typically very small, comprising a smaller ratio of its entire size. Next up is the thoracic vertebrae. Morphologically, these can be difficult to differentiate from the lumbar vertebrae, especially as you get into the lower thoracics versus upper lumbars. What's most likely to happen is that they will give a mid-thoracic vertebrae because it has a very typical appearance. The spinous process is usually long and sharp and points at a downward angle. Other things to look for are causal facets on the transverse processes. They aren't as prominent in real life as they are in textbook images, but they're usually notably simple because it is a smoother part of the bone on the tip of the transverse process. This is not seen in the lumbar vertebrae because they do not interface with the ribs. Other morphological differences are a circular vertebral foramen as well as a medium-sized body. Not too thick, not too small. Lastly, we have the lumbar vertebrae, which I've already ended up speaking a little bit about, but by way of review, these vertebrae have very large and thick bodies that take up a larger ratio of their entire size. They also have thicker spinous processes that are typically shorter and stick straight out as opposed to pointing down. Lumbar vertebrae also typically have a more triangular shaped vertebral foramen when compared to their thoracic counterparts. Here we have a quick breakdown of the cervical spine. As you likely know, there are 7 total cervical vertebrae, and in the picture on the left, you may be able to appreciate that morphologically, the spinous process of C7 does not look too distinct from T1, so the best thing you can do is look for the transverse foramen to identify these vertebrae quickly. Some other important cervical vertebrae are C1 and C2, or atlas and axis respectively, shown in closer detail on the right. The way I like to remember this is that in Greek mythology, Atlas held up the entire globe on his shoulders. Similarly, the Atlas bone, C1, holds your entire skull on top of itself. Axis is right below, at C2, and is most readily identified because of dens, the small thumb-like projection on the anterior superior surface of the bone. Some sources like to think of C2's dens as an axis of rotation for Atlas to maneuver about. Apart from that, I do not have a handy way to remember this. I just had to remember the names axis and dens. Lastly, on the photo on the right, you may be able to appreciate the small bifurcations that can be seen on the spinous processes of these 2 cervical vertebrae. In osteology lab, Derek and I noticed that this bifurcation usually extends down to C6, and then by C7, it looks more pointed as it starts to be less distinguishable from T1. In summary, the main features to look for in cervical vertebrae are the vertebral foramen on the lateral sides of the bone. These are only present on cervical vertebrae. Should that fail to remind you, you may be able to recognize some bifurcations on the spinous processes. As a last resort, you may be able to notice that these vertebrae have a very small body that takes up less than half of their total size. Lastly, it's worth reminding you to be able to identify C1 and C2, atlas and axis respectively, as well as the dens of C2. These are very noteworthy structures. So now let's review the thoracic spine, of which there are 12 different vertebrae. Here you can appreciate not only the fact that most of the thoracic vertebrae have long, thin spinous processes, but also that most of them are generally pointing downward. Then, once you reach the lower thoracics, the spinous processes begin to shorten, thicken, and face straight out. This is why the spinous process alone may not suffice to identify the thoracic vertebrae. Exams likely would not give a lower thoracic vertebra and force you to identify it, so looking for a long, thin, downward angled spinous process should work, but if it doesn't, another key landmark to look for is the causal facets on the transverse process. You can also look for the demifacets or a more circular vertebral foramen to identify these vertebrae. Lastly, we have the lumbar spine, of which there are 5 vertebrae. The main feature of these are the large bodies as well as the shorter, thicker spinous processes that, generally speaking, point straight outwards as opposed to down. So once again, lumbar vertebrae major features include large bodies, short, thick spinous processes that point outward, as well as a vertebral foramen that takes on more of a triangular shape. Should all these features escape your memory, try looking for demifacets or causal facets on the transverse processes. None of these features should be present on a lumbar vertebra.
So now we're going to switch gears a little bit and talk about 3 major ligaments of the spine. There are more. For the sake of brevity and yield, we're just going to focus on these: the anterior and posterior longitudinal ligaments and the ligamentum flavum. But before we jump into how we would identify these ligaments grossly, I think it's useful to just think about why these ligaments might be useful. What's the point of having ligaments? Well, the answer is stability. To put it simply, ligaments keep things together. They hold things in place, particularly bones. So, what exactly is a ligament? When we say ligament, all we're talking about is a tough and fibrous connective tissue that connects bone to bone. Okay? If we take the anterior longitudinal ligament here, for example, all it is this band of connective tissue in front of the body of the vertebra that helps connect adjacent vertebrae together. And if you think about it for a moment, and just imagine this ligament running up and down the whole length of the vertebral column, you can probably imagine how important having a ligament like this is for just keeping the whole vertebral column together. That's about it for functionality. But now let's take a deeper dive into how we would identify these ligaments and where they are located. First up is the anterior longitudinal ligament. And I know we just talked about this, so it should be pretty easy to think about. In terms of location, well, let's say I give you a long piece of tape, and I told you to slap it on where that ligament is. Okay, where would you put it? It would be right here. Bam! Right on the anterior side, okay? The anterior side of the vertebral bodies, okay? If we take this image to the left here, okay, where would that be? Boom, right there, okay? Anterior to the vertebral body. Next up, we have the posterior longitudinal ligament, okay? And the key here is that this ligament runs posterior, okay, to the vertebral body. Posterior, all right, to the vertebral body. And if we take a look at this image to the left here, this is just another view, okay, of the posterior longitudinal ligament. And as you can see, again, it's running just posterior, okay, to the vertebral body. And this ligament, okay, just like the anterior, is going to be running up and down the entire length of the vertebral column, okay, nice and continuous. All right, so last up, we have the ligamentum flavum. And this is a little confusing to visualize, but if we take a second to unpack it, it'll be totally fine. All right. So just to recap, we have two ligaments. We have the anterior longitudinal ligament and the posterior longitudinal ligament. These ligaments run either in front or behind the vertebral body, and they're long and continuous. The ligamentum flavum, on the other hand, is a short and thick band that is non-continuous, and what it does is it joins two lamina of adjacent vertebra together. So let's take a second to unpack that here. So here we have our vertebral body, right? And as we move up here, we have our pedicle. This would also be a pedicle here. And as we continue moving up this vertebra, this becomes the lamina, right? So as you can see, this ligament, ligamentum flavum, is joining these two laminas together. If we look at the image to the right here, I hope we can better visualize the lamina. So these are our pedicles here. This is my lamina. And as you can see, we have the ligamentum flavum in this region. And imagine it's coming at you out of the page. And imagine you're another vertebra, right? Imagine your head's like a lamina or something. And this ligamentum flavum is going to be joining that lamina, okay, to your lamina. Now, if we take a look at this image here, this is a really nice representation of how the ligamentum flavum joins two adjacent lamina together, right? So here's my lamina, right? And the ligamentum flavum is just coming across here. And the one really important thing to note, one really major concept here, is that the ligamentum flavum doesn't actually cover the lamina itself, right? As you can see, it goes from here, it stops, it's this non-continuous sheet, goes to the end of this lamina and continues, all right? And that is everything we've got. Thank you guys so much. Good luck on your finals.
Lastly, we would just like to thank Dr. Mann for taking us into the osteology lab this block and giving us the opportunity to learn about bones. Have a great exam, everyone.